except for the first layer. So if you only ever have a layer 1 protocol like, like maybe the command line arguments to LS, there's really only one layer to that protocol, if you will. So it's okay to like throw totally random crap at that. It might be better to not do completely random crap, like, if you know what the switches are, like -L, well, do a -L and then random crap, right? So you still want probably still want some ability to understand. You might want to do all random stuff last or first. I like to do it last because you do your smarter searching first, and if you don't find it, you sort of kind of open up the throttle, right, and just kind of let it go for a little longer. So which fuzzer's best? Nobody knows. There's no research, and it basically depends. I won't beat that to death. I'll blow right through context-free grammars. Context-free grammars are a way of describing something completely. Like you see there's like a transfer, and there's like transfer equals a read or a write. A read equals, a read request. A read request is a file name. A file name is a character. A character is like, so you have this complete of describing a protocol. This is how JaredDeMott writes their fuzzers. And based on that complete description, and then they can also like insert bugs or whatever, you can insert attacks in this description. So I won't really go through too much of that. One thing that Protos group, this is the Finland group, the secure programming group in the University of Oulu, that's where JaredDeMott came from. One thing that they said was really interesting, and it's not rocket scientists, but it's kind of like basic things that when you think about them in a certain way, they said that software bases could become immune to their tools. I just like that word. It was really kind of a cool term. It's basically like you run their tool against, say that they were checking BGP. They read BGP fuzzer, and they ran it against Cisco and Juniper. Cisco got a thumbs up, Juniper got a thumbs down, or vice versa, or whatever. I don't know. I'm just making this up. But you could use it as a thumb up, thumb down, but what happens is if it found 2 bugs, and so it was thumbs down, you fix those 2 bugs, you run it again, it's thumbs up, right? And that's the whole idea behind testing and being able to retest. But since there's no randomness in their tool, it's deterministic in the way it runs, it's good for QA, because you can run it again and see if you actually fix the bugs you think you fixed. But it might not be so good in terms of the fact that those code bases, say, pretend their tool is the only tool out there and it like gets popular and that's the only one anybody ever uses to fuzz. Those code bases, especially if they're like open source, like OpenSSL, like components or something like that, they truly are immune to that tool. So you run it, it doesn't find anything. Does it mean that there's bugs or not, right? You don't really have confidence in that. So it's nice that there's a lot of tools out there starting to show up finally, like GPF, like AutoDefA, that you can go and download and you can write your own fuzzers and do all this stuff too, right? So this is just kind of talking about what I was talking about, what a generic fuzzer might do for you. Like the tool I wrote, it should be able to do some capturing and some replaying. You should be able to convert to a neutral format, which I do because you can't really edit PCAP files very easily. The demo I give talks about that. Tokenize, it'll talk about that. Strong attack heuristics. Intelligent randomness, right? You don't want it to, you want your error rate to be relatively low when you're replaying according to, the functional protocol spec. One cool thing that is nice, and you're seeing more of this, is that's like dynamic information back from the target under test. Getting back data like, oh, I just crapped out. That'd be nice to know, tell the fuzzer, right? So he can stop and maybe log what he just sent, something like that. So there's some notion of data back from the target, which would be good. Really good, in fact. And distributed fuzzing was an idea I have. I don't think I've ever seen or heard of too many people doing this, but wouldn't it be cool if you wanted to fuzz some big process, like IIS or something like that, that might take a long time to fuzz because it's going to be hard to fuzz because there's not many bugs in it. Gotcha. What if you like set it up on 100 machines, started your fuzzer on 100 machines, and had some central server that was kind of like, divvied up the job, things you wanted to fuzz, and you just like open the floodgates, right? There's plenty of organizations that have the resources to do that. Okay, so I'm not one of them, by the way. So how is web and file fuzzing a little different? I just wanted to bring this up to show you that fuzzing is a little different depending on what you're fuzzing. Like for web auditing, I'm sure you guys have probably done a little, maybe there's some web auditors in here. The chance that you're going to like send bad HTTP GET requests to Apache or IIS right now and get it to crash, get the actual web server to crash, it could happen, but it's fairly low, right? What's more likely when you're editing or you're auditing websites is basically like, some dude has some crappy MyBlogger site space, whatever, and a lot of these are written in like PHP and stuff like that. Maybe they're not real good. Anybody heard of file inclusion vulnerabilities in PHP scripts? So yeah, there's some people, yeah, you've heard of that. So it's going to be kind of hard to find that with just like a traditional client-server fuzzer kind of methodology. So, because what you actually need to look for is not the HTTP server to die, but what you're looking for is error codes, like the HTTP server sends back, good, good, oh, bad. Oh, we need to, it's just sent back a bad. Maybe what I just sent wasn't good, something like that. So it's a little bit different. File fuzzing is actually really similar. Sutton actually doesn't work for iDefense anymore, but they came up with, they kind of were kind of the first ones to really go big in public with file fuzzing. There's a lot of people doing it now. If you look at Pedrum's PyMay framework, there's actually a file fuzzer built into PyMay now. So the only reason it's different is just that there's not that network interface element. So how you deliver and how you monitor is a little bit different, particularly since like if you're fuzzing Word, you need to keep delivering bad Word documents to Word. So you need to keep starting Word, kind of like I talked about before, and you need some framework to be able to do that kind of work. And PyMay is actually a good framework to do that. Create a funky file, whether dumb or smart. Dumb would be like you just randomize the bits. Smart would be like the structure of Word documents, right? And you maybe just change one or something like that. So yeah, it's a little different, but it's actually really similar in terms of what it's doing. So fuzzing metrics, let's go through this. Martin Vegno that came up with AutoDeface, good tool. He was the first to kind of do any sort of formal computer science study, I think, on metrics for fuzzing, which is good. And it's really not rocket science. It's actually really simple to understand. All he said was basically the number of substituted variables, which is like his library, L, of all. So he has 10,000 bad strings that he wants to fuzz with. And say like, for user and pass and all these, he has maybe like, whatever, 10 or 100 or whatever. You just times them together basically, and if it's like a second per transaction, you can actually get a metric on how long you think it's going to take to fuzz this particular server, which is a really useful thing to know, particularly for QA type people. They'd like to know how long is this going to take to run. And he actually went a step further, which is really cool. Since he debugged the target process, he can actually say, well, when you send user space Jared, the Jared is consumed by a stir copy. Well, that's interesting. That's better than just the user. So let's fuzz that first. So he orders his complexity. So you have an ordered complexity, which is, again, not rocket science in terms of what's done in computer science, but it's really cool stuff for this kind of field because there haven't been a lot of people to do kind of a formal study on fuzzing like that. So, and those are like some of the naughty functions out there that his thing actually looks for. So it's pretty cool. My thing is like I'd like to see people do. Some people are like, you should only use a list of strings because like sending random crap is irrelevant because like we already know the list of the heuristics and stuff like that. I'm like, nah, do that first if you want. And then, do some more randomness, randomize the position of where some random stuff might get in. Maybe you don't know, right? You tell your tool just to pick a spot. First leg, seventh leg, 10 legs deep in the protocol. Pick a position, pick some random data, you know what I mean? Do some of that. Randomness, I like structured testing, but I like some randomness too. And the research I'm going to be doing this year, so maybe if it's successful and you all come to DEF CON next year, maybe I'll talk there. I'd like to use, again, genetic algorithms to try and have a fuzzer sort of learn where it's not working well. Maybe by using some code coverage metrics or something like that, have it be fuzzing and be like, oh, you know how evolutionary computing works. It's sort of like you have a generation, right, of parents, and it's sort of like when I sent I got 8% code coverage, and that was the best of the group. All the other ones only got 3% code coverage. So maybe I should breed, those parents or something like that. And maybe now I get 9% code coverage. So it's sort of automatically learning the protocol and automatically being able to cover more of the binary. So you have to be able to monitor the process and send stuff back. And I don't know how to do this yet. I haven't been able to successfully do this or anything like that. I'm just now starting my research on it. So hopefully by like April or something, I'll be done with that. And that would be really cool. So I think I want to just go into the demo, and hopefully we'll have a few minutes for questions at the end. The demo is just a little video of, why do I have a lot of sessions of that up? That one's still up too. Really cool. Okay. Can you guys see that or hear that?
I'm going to demonstrate a tool I wrote called GPS.
Can't hear it?
I was jokingly called the General Protection File. GPS actually stands for General Purpose Fuzzer. If you're not familiar with fuzzing or have never heard of the term, stay with me. Fuzzing is simply an automated testing technique used to discover implementation issues or bugs.
Can't hear it, can you?
Quality assurance folks
Well,
call this activity
basically, I'll tell you what I'll do. I'll just turn the volume down on it up here, and I'll just kind of tell you what's going on. Basically, I'm just showing some of the uses of my tool there, and to start off with, I'll just basically send totally random crap at SSH, right? Just maybe a first test, because SSH is a little hard to fuzz right off the bat, right? Because it's an encrypted protocol. So if you really want to fuzz deep into SSH, you're going to know a little bit more about the protocol. For example, you're going to have to be able to do some cryptographic handshaking, right? So maybe you don't want to do that. Maybe you just want to say, hey, I'm just going to wing it. I'm screw that intelligent fuzzing. I'm just gonna blast off, right? I don't know if you can see that at all, but I'm just like typing, the IP address and stuff, and it just starts sending totally random packets, just totally random crap UDP packets at a target. And that's found bugs amazingly in the past, but it's not the greatest way to fuzz in the world, right? Because it's not all that. So, depending on the protocol, here I'm just going to show you how I took an FTP capture that I had created with Wireshark. I captured an FTP session, and I try to cat the file. Oh, man, that doesn't look too good. I better reset my terminal. And then I want to convert it to this middle format. I call it a .gpf file. Because suppose you want to fuzz when the username is valid, right? That's going to hit a certain code path. But suppose you want to fuzz when every time you say a name that's not valid, that might fuzz a different path, or when the password's valid or the password's not valid or something like that. So it's nice to have a way to be able to edit these files really quickly and just say, I have an idea for a test. What if I use a valid username and then I log out on the same line? I've actually found some really weird bugs like this where you do like a log out, but you don't do the /r/n. Just do like a /r instead of both, and then do like a login again or something like that. But all on the same line, because FTP expects like multiple commands on the same line, stuff like that. Found some bugs in IMAP doing stuff like that. You can come up with various kinds of tests really easily like this, and actually, there's ways that GPF can come up with those sort of tests for you on a more random basis, but if you have a targeted test, that's a really good way to do that. So you saw me edit that file, and I changed, the username or something like that. Now when you cat it, that's actually just me. I actually have, like, in each one of these directories, I have like a -gr client.sh, because GPF, like, the list of arguments is like, 16 arguments or something like that. It's a little gross. So I have like a whole bunch of I have just like little shell scripts in each directory so that you don't have to remember what all the various arguments might be. So that was just me like replaying a file. You saw like it said, okay, give me, like, I'm an FTP server, and I said, this is my username. He said, yeah, you're good, and then password. So just that same example that I talked about at the beginning, just again so that people can understand and see, this is how I could really fuzz something. It's really not that hard to think. Sometimes people think about fuzz, think, I can't do that. That's only for like really smart people and vulnerability researchers and people that are going for a PhD, which I never thought I'd do because I'm not really that smart. But as we were talking about earlier, it's all about perseverance, right? Education, has anybody been through the educational system? It's more about perseverance than smarts. Is that true? Anybody say amen to that? I know I feel that way. So, but anyway, that was what I was just showing there. That was the side of an FTP session. So now I'm setting GPF to run as an FTP server instead of the client. And you see me with an FTP client in Windows. I'm clicking on try to connect to GPF, try to connect, click, try to connect, click, try to connect. And that's actually a really bad way to fuzz, right? Because you don't want to have to manually intervene when you're fuzzing. That's a terrible way to fuzz. But I showed it because it's funny. It actually worked. I actually found a bug in that FTP client. And I never reported that, I don't think. But